Welcome to The Explainer. Today, we're digging into the fragile confidence of artificial intelligence and a hidden flaw that could completely change how we think about trusting these incredibly powerful tools.
Okay, so this whole thing really starts with understanding the difference between two kinds of questions. On the left, you've got a simple, factual question. Which hormone is associated with type 1 diabetes? The answer, of course, is insulin. Clear cut. But on the right, you have a much more complex, ambiguous question. What medication should be taken for type 2 diabetes? There are a bunch of valid answers, right? It depends. And this difference, this is at the very heart of AI's biggest challenge.
And that right there, that gets us to the core issue. As we start handing over really high-stakes decisions to these large language models, for things like legal advice or even medical diagnoses, we absolutely have to know when their answers are reliable. So how do we measure an AI's confidence?
You know, for a while, it really seemed like the AI community had this problem licked. They thought they had a solid way to get a clear confidence score right from the machine.
The big idea was this thing called uncertainty quantification, or UQ for short, and you can think of it like, well, it's the AI's ability to tell you, hey, I'm 95% sure about this answer, versus, I'm only about 30% sure. It's an absolutely critical feature if we're ever going to build trust.
And for those simple questions, the ones with a single correct answer, these UQ tools worked beautifully, really well. They could reliably tell us when the AI was sure about a fact versus when it was just kind of guessing. It honestly seemed like the problem was solved.
But, and this is a big but, this is where the whole illusion starts to fall apart. See, researchers started to realize that not all uncertainty is the same. The real world is messy, and an AI can be confused for two very, very different reasons.
Okay, so the first kind is what's called epistemic uncertainty. And you can just think of this as the AI saying, I don't know, right? It's just a gap in its knowledge. The great thing here is you can fix it. You just feed it more data to learn from. It's a solvable problem.
But then there's the second type, and this one is way, way trickier. It's called aleatoric uncertainty. This is the AI basically saying, hey, this is just complicated. Think back to that type 2 diabetes question. There's no single right medication for everyone. This kind of uncertainty, you can't just fix it with more data, because it's baked right into reality itself.
And right here, this is the bombshell. It turns out that those UQ tools, the very ones we were relying on to measure an AI's confidence, they literally cannot tell the difference between I don't know and it's complicated. They just mash both types of uncertainty together into one single and often super misleading score.
And this visual just nails it, right? On the left, you've got the simple case. The model's trying to hit a single target, the star. It's black and white, right or wrong. But on the right, well, that's the real world. The correct answer isn't a single point, it's a whole area of possibilities. And the problem is, our tools were built for the world on the left.
So, a team of researchers at the Technical University of Munich saw this and thought, okay, let's prove it. They decided to build a test specifically designed to break these measurement tools by throwing all this real-world ambiguity at them.
And how'd they do it? Well, they created these brand new datasets. And for the very first time, these datasets were built without a single right answer for every question. Nope, they were designed to mimic the messiness of the real world, where lots of answers can be valid. This was a totally new way to put AI to the test.
So first, they ran the tests on the old, simple datasets, the ones with clear-cut answers. And what happened? The UK methods performed great. They got a score of 0.85. And just so you know, 1.0 is perfect, and 0.5 is basically flipping a coin. So this confirmed that, yeah, for simple stuff, the tools work.
But then came the real test. They ran the exact same tools on their new, messy, ambiguous datasets. And the performance? It just collapsed. It fell all the way down to 0.51. That's barely better than random guessing. The AI's ability to know when it was confident just evaporated.
And this graph just says it all. You can see right here as that its complicated factor, the aleatoric uncertainty, goes up. The performance of every single one of these UQ methods just tanks. They don't get a little worse. Their reliability completely falls off a cliff.
So look, the big takeaway here is that this isn't some small error we can patch. It's a fundamental breakdown. The tools we built to tell us if we can trust an AI, they fail us right when we need them most, on the tough, ambiguous problems. So when an AI tells us it's uncertain, we have absolutely no way of knowing why. Is it because it doesn't know the answer, or because the question itself is just that hard?
And you can see why this isn't just some abstract academic thing, right? This has huge implications for pretty much every field that's looking to use AI for serious real-world decisions. I mean, the researchers of Zell said it perfectly. They said this work should cause a paradigm shift. A paradigm shift. That means we can't just tinker with the old tools. We have to start from scratch and build completely new methods, ones that are designed from the get-go to understand and tell us what kind of uncertainty the AI is dealing with.
And so that leaves us with a really big, challenging question. I mean, if we can't tell why an AI is uncertain, can we ever really, truly trust it with our most important questions? Right now, it seems like our trust in these systems might just be built on an illusion.